Sup everybody, Sonal here. What if the speed of light got slower? First of all, what is speed of light? In the general term, the speed of light is the distance that light covers up in a certain amount of time, approximately 299, 792, 458 meters per second. In a mathematical perspective, the speed of light is a constant denoted by c that can be seen in various equations such as Albert Einstein's special equation E equals mc squared, or otherwise known as mass energy equivalence, that predicts everything that having mass has an equivalent amount of energy and vice versa. If we look back into the history of the discovery, we can see that in 1676, Ole Roma demonstrated that light speed is finite by observing the apparent motion of Jupiter's moon Io. And in 1865, James Clerk Maxwell proposed that light was an electromagnetic wave and traveled at the speed of c, appearing in his theory of electromagnetism. In 1905, Albert Einstein postulated that the speed of light c with respect to any initial frame is a constant and is independent of the motion of the light source. But until scientists precisely measured light speed to be exactly c in 1975, no one knew the exact measurements. The only scenario that we can observe the speed of light to be exactly c is in a vacuum, because in a medium like air, light chooses a longer path through atoms and molecules and therefore result in speed of light being slower. As an example, light propagates through glass 1.5 times slower, or roughly 200,000 kilometers per second, and the refractive index of air is 90 kilometers per second, or 56 miles per second slower than the speed of light in a vacuum. But the speed of light is not enough to travel between two stars, or even in a smaller perspective, two planets, because as an example, it takes a minimum of 3.03 minutes for light to travel from Earth to Mars and vice versa. This results in extreme gaps in communication. This is one of the major drawbacks in Mars colonization. If we look into the consequences of speed of light being slower, we can observe that it would have a great impact on physics and the current understanding we have on the universe. For example, fundamental forces of the universe such as gravity, electromagnetism, strong nuclear force and weak nuclear force, and equations such as previously mentioned Albert Einstein's equation will be disrupted. Also, it would have a huge impact on chemistry due to the reason being speed of light affects chemical reactions and for them to take in place in the universe. If the speed of light got slower, it would require huge amounts of energy for chemical reactions to take in place. So, if we consider the speed of light to be exactly 100 miles per hour, we would require new transportational methods, because just traveling at the speed 0.01 miles per hour would require you a rocket or a nuclear powered car. Also, no long range communication will be possible as we currently experience, because 100 miles per hour equals roughly 45 meters per second. Therefore, sending a message to a person who is opposite side of the earth would take a minimum of 5 days and 4 hours. But if we consider the light speed to be lower, we have to ignore the fact that earth rotates at about 1000 miles per hour, or 460 meters per second at the equator, and other stuff. Also, no need of your luxury watch that you bought to impress your buddies, because the act of walking around would cause you to lose an outrageous amount of time that is equal to half a second for every 1 mile you walk. But as counterintuitive it might get, if you started moving around in a car at a high speed around 65 miles per hour, then you could expect to lose around 17 seconds for the exact 1 mile you travel. Now let's get into some exciting stuff. Super speeds. One of the slick things about traveling at relativistic speeds is that although you can only pass things up to 100 miles per hour, you can cover more distance in that same amount of time. There are two main ways to approach this question. From your point of view, the world around you undergoes length contraction. For example, at about 87 miles per hour, you would observe that the world around you undergoes length contraction by a factor of 2. So, while you would see things pass you by at 87 miles per hour, you would eat up distance as though you were traveling at 174 miles per hour. From everyone else's perspective, you are traveling through time slower. At about 87 miles per hour, they would see your previously mentioned clock ticking as half the usual rate. What about pretty colors? Even at running speeds, there would be enough relativistic Doppler shift to change colors around you. If you are driving past a yellow field of grain, it would appear blue in front of you and fade to a deep red as it passes behind you. There's a game developed by the students at the University of MIT that visualize how would it look like when the travel speed of light got slower as much as walking speeds. As we play this game, we would observe many relativistic effects such as time dilation, length contraction, and Doppler shift. As the speed of light got slowed down, you would see that the Doppler effect gets stronger and stronger. At the same time, the reason for the increasing brightness is that as the speed of light slows down, more protons hit your eye. As we move away, the intensity of the brightness slows down, making the brightness low and dimmer, and at the same time, redshifted. A real-life example for Doppler shift is stars shifting towards red, and the reason being stars and galaxies are moving away from you for the reason being the expansion of the universe. Now let's get advanced in the topic. When you move closer to the speed of light, your time relative to somebody whose motion through space is at a race decreases. This applies for everything. So the only way to live longer than usual is to travel at the speed of light. So to understand this, the connection between space and time is extremely powerful as mentioned in special relativity, as the fourth dimension is time. In that theory, it is mentioned that if your movement through space is at a rest, you are traveling through time. But when you are moving through space, something must give up. Therefore, your time slows down. When you move through space at the speed of light, your time freezes. When considering length contraction, the actual process that is taking place is things get squished together. But for the subject that is moving at the speed of light, it seems like things get stretched out and somewhat rotated. But the reality is things get squished together. Another interesting topic covered by Vsauce in his video Would Headlights Work at Light Speed is if two spacecraft, that one is stationary in space and the other spacecraft traveled at 99% the speed of light and turn on headlights, would the light beam emitted by the spacecraft that is traveling 99% the speed of light would be faster? No, because as we covered earlier, when traveling at relativistic speeds, your time slows down. But first, we must keep in mind that light beam from the faster moving spacecraft is shorter. But because their time relative to the other spacecraft that is slower, they will not feel the light to be shorter. When they complete their 1 second, they will observe that the light beam is traveled the exact light speed distance. We can be sure about this because in Albert Einstein's general relativity, it is predicted that time is relative to the observer. This is for the most part will be hypothetical because neither you can see anything at light speed or anything that having mass can travel at the speed of light. At that high speed, the subject could travel billions of light years without even realizing that even 1 second is passed. In the simplest term, the concept time does not apply for something that is moving through space at the speed of light. For example, photons that's not experience time. That means a photon emitted by a faraway galaxy toward us will not feel time in their time frame. So at the end of the day, this is the reality we live in, and the speed of light is a constant that we can't change. So this is totally science fiction. If the light speed was slower to the point where walking speed is the speed limit of the universe, physics as we know today will be totally different. This could be the reality for another parallel universe, but it's a whole new topic for another video. Peace.